Today we will see different questions asked in a civil engineering interview. First one is volume of slump cone. This is a slump cone of lower big dia is 0.2 meter, upper small dia is 0.1 meter, height is 0.3 meters. Slump cone shape is called frustum. This is called frustum. So for calculating volume of a slump cone, you have to calculate volume of frustum, which is pi h by 3 big R square plus big R into small r plus small r square. So here big R is big D divided by 2, that is radius is half of dia. So here big R is equal to big D. So big D by 2 is equal to 0.2 by 2, that is 0.1 meter. Then we have to calculate small r, which is small d by 2. Small d is 0.1 meter divided by 2, that is 0.05 meters, and h is 0.3 meter, which is already given. So put all the values: 3.14 value of pi into 0.3 by 3, 0.1 into 0.1 plus 0.1 into 0.05 plus 0.05 into 0.05. We get the volume of slump cone as 0.005495 m3. It is volume of slump cone. Next, we have to calculate why do we use 150 mm size cube for compressive strength test. Here, if you are checking M30 concrete, we need strength of 30 Newton per mm square, and if the size of cube is 150 mm, the load required is 742.5 kilonewton, which is safe and easily applied. But if we increase the size to 300 mm, then the load required will be 2970 kilonewton, which is risky and not practical. For example, we are testing M30. We need 30 Newton per mm square strength. For obtaining 30 Newton per mm square, as we know, if we have to calculate compressive strength, its formula is load upon area. So we take 742.5 kilonewton load, and area is 0.15 into 0.15. We get 22.5. (33 Newton per mm square is compressive strength for 30 Newton per mm square cube. And if we take 0.3 meter cube, 0.3 by 0.3 meter cube, you have to take load as 2970 by 0.3 into 0.3, 2970 by 90, we get 33, that is 30. So it is clear, for 0.15 meter cube, load required is 742.5 kilonewton only for achieving 30 Newton per mm square strength, and for 0.3 meter cube, load required is 2970 kilonewton for achieving 30 Newton per mm square strength. So this is risky. That's why we use 0.15 by 0.15 meter cube. Then, and 150 mm cube is ideal for 20 mm size aggregate, which is commonly used. If we make small cube, the concrete will be ununiform. So as we use 20 mm size aggregates and we put in small cube less than 150 mm take 100 mm, then the concrete mix will be uniform. It will be full of aggregates. So we use 150 mm cube. If the cube is too big, it will be difficult to handle and load required will be more. And if it is too small, then we will not get true strength due to large coarse grain present and uniformity in concrete. Therefore, 150 mm cube is the most ideal size. Third question is compressive strength of concrete cubes in different days. For 3 days, compressive strength is 40% strength. For 7 days, 65% strength. For 14 days, 90% strength. And for 28 days, 99% strength. For example, if we take M50 grade, M50 grade, so for 7 days, what is the strength required? You calculate it by simply multiplying 50 by 7 days is 65% strength. Therefore 0.65, we get 32.5 Newton per mm square. So 32.5 Newton per mm square is the strength of a M50 grade concrete cube on 7 days. Fourth question is, what is creep in concrete structures? Creep in concrete is the deformation of a concrete structure over time due to constant load or stress. Here a beam is given in which load is applied and there is no deformation. And second diagram shows a beam deformed with the applied load, and this deformed beam can be called as creep. Thank you.